This is Chapter 4, Lesson 5, Compare Properties of Functions. Okay, so if I'm comparing two functions, it says functions can be represented by a table, graph, equation, or words. You can compare two functions represented in different forms. So, example number 1 says a zebra's main predator is the lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. Compare their speeds. To compare their speeds, I compare their rates of change. Okay, so I'm going to have two colors. Lion is going to be purple, 53 feet per second. And zebra is going to be pink. Okay? So if I look at my table here, or my graph, this is for my zebra. Okay, so this is my graph for my zebra. So this tells me a zebra can run 59 feet per second, right? So I'm comparing their rates of change. So here's my zebra. Okay. A lion can travel at a rate of 53 feet per second. To find the rate of change for a zebra, I choose 2 points on the line and find the rate of change between them. So they took 2,118 and 1,59. And I subtract and I get 59 over 1. So that's my rate of change for my zebra. So a zebra can travel at a rate of 59 feet per second. Since 59 is bigger than 53, the speed of a zebra is greater than the speed of a lion. Okay. Number 2 says the function m equals 140h, where m is the miles traveled in h hours, represents the distance traveled of the first Japanese high-speed train. The distance traveled at a high-speed train operating today in China is shown in the table. Assume the relationship between the two quantities is linear. Okay, so here's my first function. So here's my train to Japan, for Japan. Here's my train for China. So I'm going to be in purple. Okay. So letter A says compare the functions y-intercepts and rates of change. So I'm going to compare the y-intercepts. At 0 hours, no distance has been covered, so the y-intercepts are the same. Okay. Compare the rates of change. The speed of the Japanese train is 140 miles per hour. Use the table to find the speed of the Chinese train. Well, I can figure out that the Chinese train goes 217 per hour. Okay? Every time I go up by 217. Use the table to find the speed of the Chinese train. The speed of the Chinese train is 217 miles per hour. Okay? Since 217 is greater than 140, the function represents the Chinese high-speed train has a greater rate of change than the function representing the Japanese high-speed train. Okay. For letter B, it says, if you ride each train for 5 hours, how far will you travel on each? So on the Japanese train, I can use the function. Find the distance of the Japanese train. M equals 140h. I plug in 5 for h. So 140 times 5 is 700. You will travel 700 miles in 5 hours on the Japanese train. And then I can find the distance on the Chinese train by extending the table. You will travel, so if I go up by 217 each time, here's my Chinese train. So you will travel 1,085 miles in 5 hours on the Chinese train. Problem number 3. Financial literacy. Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y equals 0.15x plus 49, where x represents the minutes and y represents the cost. Benjamin's monthly cost is shown in the graph. So this tells me his cost for the first one. Okay. So A says compare the y-intercepts and rates of change. The function for Angela's bill has a y-intercept of 49. So all I did was I took 0 into the function and applied 0 in for x. So 0.15 times 0 is 0 plus 49 is 49. You can see from the graph that the function for Benjamin's bill has a y-intercept of 60. So Angela has an intercept of 49. Benjamin has an intercept of 60. So Benjamin has a greater initial cost. The rate of change for Angela's monthly bill is 0.15 cents per minute. Find the rate of change for Benjamin's bill. So his is change in cost over change in minutes. So I picked 2 points and I subtracted. So I get 80 minus 60 over 200 minus 0. 80 minus 60 is 20. 200 minus 0 is 200. So I get 20 over 200, or 0.1. The rate of change for Benjamin's bill is 10 cents per minute. So Angela has a rate of change of 0.515 cents per minute. So Angela pays more per minute than Benjamin. Letter B says, what will be the monthly cost for Angela and Benjamin for 200 minutes? Okay, so I can easily plug this back into my function so that I can do this. Angela's monthly cost is represented as y equals 0.15x plus 49. At 200 minutes, Angela will pay 0.15 times 200 plus 49, or $79. I can use the graph to find Benjamin's cost. At 200 minutes, according to my graph, so here's my graph. At 200 minutes, Benjamin will pay $80. So go back down here. You can see Benjamin will pay $80. Okay. Number 4, financial literacy. Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table and graph. Which company should she use to rent the truck for 40 miles? Okay, so here's my graph. So that's for cross-town movers. They're going to be purple. Okay, and then here's my table for Ron's rentals. They're going to be pink. Okay. So I have my 2. So I want to find the cost of renting a truck from Ron's Rentals by extending the table. So after 40 miles, the cost will be $75 plus $25, or 100 miles. Okay. So that's for Ron's Rentals. Because if I just extend the table here, right? So here's my table. At 10 miles, it's 25. At 20 miles, it's 50. At 30 miles, it's 75. So each time I'm going up, here I'm going up by 25. Here I'm going up by 10. So 40 miles, I'm going to add 25, so I would get 100. Okay, so that's where I get this from. Okay, so I find the cost of renting a truck from crosstown movers by looking at the graph. The y-intercept of the graph is 30, so the slope or rate of change is 45 minus 35 over 30 minus 10, or 0.5. So the equation, y equals 0.5x plus 30, where y represents the total cost and x represents the miles drive can be used to find the total cost of renting the truck. So after 40 miles, the cost will be 0.5 times 40 plus 30. And when I multiply all that out, I get $50. So crosstown movers would cost less for 40 miles. Okay. On page 95, there are a couple of try it problems. I want you to go ahead, pause the video, try them out, and when you are done, we will go over the answers together. All right, now that you've had a chance to look over the problems, let's go over the answers together. Letter A says a certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sports utility vehicle is represented by the function shown. Compare their gas mileage. Okay. So, first one has 22 miles per gallon. Then I can look at the graph over here. The sport utility vehicle is 19 miles per gallon. So the car is 22 miles per gallon and the SUV is 19 miles per gallon. So the car has the greater gas mileage. So the car has greater gas mileage. Okay. The second scenario I have is the number of new movies in a store receives can be represented by the function m equals 72 plus 2. Where m represents the number of movies and w represents the number of weeks. The number of games the store receives is shown in the table. This should be 72w. So the function is m equals 72w plus 2. Okay. All right. So now, letter B says compare the functions y-intercepts and rates of change. All right, so the first one for letter B, for the first function, y-intercept of 2 okay, then and in the function, the video games has a y-intercept of 0. Okay. Sorry, this function should be 7w. 7w plus 2. Okay. So y-intercept of 2 and a y-intercept of 0. So the purple is going to be my movies and the pink is going to be my games. So my rate of change, so the store receives 7 movies. So rate of change is 7. And and rate of change for the games is 3, because you can see in the table that during the first week they received 3. So for this one, for letter B, the rate of change for the movies is greater. Okay. Letter C says, how many new movies and games will the store have in week 6? Okay. So for letter C, I'm just going to take my function 7w plus 2. I'm going to plug in 6 for w. 7 times 6 is 42 plus 2 gives me 44. So there'll be 44 movies. And then for my games, I can notice in the table that it's going up by 3 each time. So 2 times 3 gives me 6, 3 times 3 gives me 9. So I can multiply 3 times 6, which gives me 18. So there's 18 video games. Okay. My other try it problem, which contains D and E, says financial literacy. Manny and Sarah each have a membership to the gym. Mandy's membership is represented by the function y equals 3x plus 29, where x represents the hours with the trainer and y represents the cost. The cost of Sarah's membership is shown in the graph. Okay, so Manny, or Mandy, I should say, is going to be purple. Y equals 3x plus 29. And Sarah is going to be pink over here. So Sarah, here's Sarah down here. Okay, Sarah's down on the graph. Okay, so letter D says compare the y-intercepts and rates of change. So for letter D, I have a y-intercept for my first of 29. So that's from Mandy. And then Sarah's y-intercept is 39, if I look at the graph. Okay, so it's right here, 39. All right, my rate of change. My rate of change for Mandy is $3. Okay. And then for Sarah, her rate of change, I can look at the examples up here. So I'm going to actually figure out my rate of change. I'm going to take 2 points, these 2 points, 51 minus 39 over 4 minus 0. So I get 12 over 4, which equals 3. So Sarah's rate of change is also 3. So Sarah has a higher initial cost, but they pay the same amount per hour. Okay. Letter E says, what will be the total cost for Mandy and Sarah if they each have 4 hours with the trainer? Okay, so for Mandy, I have y equals 3x plus 29. And I want to know for 4 hours. So 3 times 4 is 12, plus 29 will give me 41. So Mandy will pay $41. Okay. And Sarah also works for 4 hours. So that's 12 plus 39 is $51. Okay, so Sarah will actually end up paying more because she'll pay $51. And that is the end of lesson 5.